Hello! Welcome to this three-part video workshop on streamlining the shop floor. Let's begin by thinking about production facilities in general. Now, there are three important topics which are of great general interest: increased product variety, small lot production, and faster production for quicker delivery. The problem is that many people still think that mass production is really the key to reducing costs and maintaining quality. They may want to move to small lot production with more product variety, but they worry about setup changes, lack of parts, defects, lack of product stock, and so on. Where to start? That is the problem. There is also a natural tendency to think that the status quo is best. However, if you really want to improve your production, you have to be prepared to change your system completely. In these videos, we'd like to show you some examples of Japanese companies which have succeeded with shop floor innovations by getting rid of fixed ideas. In Volume 1, we'll look at process raising in an auto parts factory. And in Volume 2, we'll examine how an apparel maker applied 5S with imagination. And in Volume 3, we'll see how a plastics maker got rid of waste to implement full flow production. And I'll be popping in to make comments. See you later.
Shizuoka Prefecture, about 150 kilometers from Tokyo, is the location of the Kikugawa plant of Mikuni Corporation, the auto parts manufacturer. This production facility separated from the company's main Odawara plant in 1978, and it's now proud of being #1 in the world for carburetor production, boasting 550,000 units per month, mostly for motorcycles, but also for light four-wheel vehicles. Since the second half of the 1980s, there's been a steady decline in the demand for carburetors as a result of three main factors: the sharp rise in the value of the yen, the backlash effect of American auto import controls, and the high-class car orientation of the domestic market in Japan. In addition, there's been pressure to increase small lot production with increased variety in the face of declining sales. A survival plan was urgently required. Mikuni came up with a way to double production while eliminating defects. They called it the buy-buy strategy. The first buy meaning to multiply by 2, the second meaning to increase productivity by eliminating defects. As a slogan, it may not win any prizes, but at least it effectively suggests bye-bye to defects in general. In June 1987, every member of staff was given a small blue notebook. Let's ask a few members of the staff about them. Excuse me, are you carrying your blue notebook?
Hi.
Could I have a look? What's written inside it?
作業者として働く上での重要項目として、目標定義づけのようなものとして、記されており、その他のものについても細かく記されている手帳ですけど。
Excuse me, do you have your blue notebook with you?
持ってます。
Have you got your blue notebook?
はい、持ってます。
What's written in it?
機械機を作るための基礎知識とか、今金額工場で展開しております売買作戦の目的目標などが書かれております。
In fact, under the title Basic Knowledge for Producing Vaporizers, there's nothing about actually how to produce vaporizers. Instead, there are 60 general guiding principles on how to produce better products, entitled Productivity and Quality Improvement Guidelines. So what was the idea behind the distribution of these notebooks? Let's ask the former factory manager.
The idea of producing the notebooks was to transfer the fundamentals of work standards and the proper attitudes toward work to each person individually, so that everyone could grasp the meaning of the buy-buy strategy. The notebooks worked like a driving force to help achieve our target of doubled productivity.
So, the first thing that's needed for production improvements is a revolution in the way people look at things. It may not be easy, but we have to get rid of fixed ideas. The equipment, its layout, and work procedures can be changed readily once the workers start looking at ways to do things with a fresh perspective. But change has to come from the top first of all. Let's hear what the factory manager has to say about the bye-bye strategy.
To put it in simple terms, we wanted to say hello to increased productivity and bye-bye to defects. Our target was to double productivity, work satisfaction, quality, and space, and eliminate complaints, defects, and waste. In other words, we wanted to multiply productivity by 2 within 3 years and eliminate defects so we could guarantee perfect quality. We had 4 main pillars. The first was to decrease defects. The second was to improve productivity. The third was to increase the rate of operation, and the fourth was to proceed with automation.
The bye-bye strategy was launched in July 1987, based on the factory's guidelines for doubling productivity and increasing the accuracy of products. At first, there were just 5 members in Yamamoto's project team.
Apparently, Mr. Yamamoto had no clear ideas at first as to how they should proceed. Naturally, they went through a trial and error period, experimenting with general line improvements and model lines. But in the end, he needed to consult with Mr. Inoue, the company vice president.
Basically, Mikuni hadn't put much research into one-step setup or the creation of U-lines. Neither the Kikugawa nor the Odawara plants knew how to implement 5S or set up efficient U-lines. I researched the fundamentals myself by going to a number of related companies to see how they dealt with setup and the creation of U-lines. I gradually learned how to do it through a process of trial and error at the Odawara plant. I recommended them to do the same at the Kikugawa plant, and I told them not to do it all at once, but to proceed with it one section at a time.
Yamamoto faced a big challenge. He had to work out how to go about process raising and what to do about U-lines. Were U-lines really desirable or not? He decided to visit a company already using U-lines to find out for himself. Two months after the launch of the bye-bye strategy, he decided to set up a process raising study group to really work out the strategy in concrete terms. It included the section chief of the manufacturing department.
Let's just think about their situation. The carburetor production line had always been a straight I line. Around 10 different carburetor types were set up on the line every day. There was clearly a lot of waste resulting from downtime during setup. It seemed possible to avoid a great deal of setup time by introducing U-lines, and that's what they did.
U-lines and the specific aim of achieving 0 setups were both introduced in December 1987, 6 months into the strategy. In January 1988, as a result of work sampling tests on the processing lines, it became clear that 7.2% of the operator's time was spent simply returning to the original work position. In early February, Yamamoto instigated a dramatic change from 62 I lines to 66 U lines. Although the number of lines had increased, there was actually a great reduction in the overall number of staff required and greatly improved flexibility. This was the first major concrete step in the bye-bye strategy. It was no easy task. the number of members of the project team was increased considerably. The section chief of the manufacturing department was the man in charge of the actual shop floor changes. Let's hear his comments.
Previously, we'd experimented with changing 1 or 2 odd lines, but it was a totally new experience for us to change more than 60 lines at the same time. Looking back, it was quite a risky thing to attempt to do it all ourselves. However, once the first few lines had been completed, everyone got more confident and more eager to do it. We created not only basic U-lines, but several variations as well. And by thinking about how to increase efficiency, we could create exactly the shape of line we wanted.
The results of the change on the processing lines were enormous. In the case of the assembly lines, during the first stage of improvement, they reduced the number of workers on each I line from 15 or 16 down to 13. In August 1988, the second stage of improvements consisted of the introduction of large-scale U-lines.
Assembly of carburetors was done with an average of 15 people per I line. The basic time taken for an operator to finish their own operation and pass the work on to the next operator, in other words, the tack time, was 10 to 15 seconds. But of course, some people worked faster than others, so group coordination and therefore efficiency was not very good. There was no way productivity could be improved with the I lines. But U lines ensured a regular flow time for each product, and the workers became multi-skilled as a result. Setup time was reduced and productivity increased.
There were 20 I lines for assembly of carburetors for two-wheel vehicles, multi-purpose vehicles and light four-wheel vehicles. Over a 2-month period, these were converted into 60 U lines.
大きさにすることができたということで、スペースの有効利用ができたと思います。それからあとは、人数を減らしたということで、直線ラインではできなかった多工程持ちが部分的ではありますけれども、多工程持ちが実現できたということだと思います。組み立ての生産効率も約 20% はアップしたんではなかろうかと思ってますけども。
The creation of U lines for all processing and assembly operations was achieved during the 8 months from February to October 1988. Over an 8-month period, 461 staff worked on 72 days to move 643 machines. The total working hours involved were 4,392 and 124 U lines were created. Of course, the improvements were made while production continued. So what was the secret of being able to proceed with such major improvements so smoothly and in such a short period?
Well, one of their secrets was to reorganize the electrical wiring and air pipe systems. This was done very cleverly, so that lines could be set up in the future anywhere they were needed.
The reorganization was by no means a small investment. The cost of refurbishing the system was around $170,000 for the air piping and $590,000 for the flexible electrical lines. But the effect was considerable in facilitating any future improvements. 2 of the core members of the project team give their comments.
自分の頭の中には何もなかったもんで、でもやれたと。やれた。それは徐々にやっていって、こういうふうにやっていけばできるなっていうのが分かってきたもんで、できたんじゃないかなと思います。
いろんな組み立てに対してもですね、ボディが供給されなかったっていうのもありますね。そうですね。この加工としての組み立てに対しての供給っていうんですか、それがやっぱり満足できる状態じゃなかったんですね。
By the time the U lines were all completed, Yamamoto was already thinking about the next step of the strategy. Although there had been obvious improvements, the target figures of halving the manpower while doubling production had not been achieved. So what else needed to be done? No simple solution suggested itself, but it was clear that modifications would have to be made to the U-lines to provide even greater flexibility. Yamamoto set up targets for the third stage of line improvements. The idea was to develop different sorts of lines according to the volume of production. Dedicated lines for large volume production and simple customized automation for small volume production. To the members of the project team, strict instructions were given to produce the customized machines that would be needed.
We were given 4 basic instructions. The first was to produce the recyclable customized machines required for small lot production of a wide variety of different products. The second was to produce customized machines in order to shorten setup time. The third was to produce customized machines to concentrate on 0 defects. The fourth was to produce customized machines for one worker operation, concentrating on efficiency. We were told that all 4 of these types of machine had to be produced. We were like a group of amateurs at this particular game, and I wasn't so confident we could succeed. Only 2 members had previously been involved in the production of customized machines, but of course, they couldn't do everything. For the rest of us to educate ourselves, we decided we needed to produce a manual first and put in some hands-on work to familiarize ourselves with the machines. In the end, things went smoothly, and we realized exactly what we had to do.
With everyone's combined efforts, this machine was redesigned in just 5 days to create a fully customized Mikuni original. This automated direct transfer line was created to reduce the number of operators. So what were the results of the improvements?
With an ordinary line, there are various types of machines, each doing a specialized job. This makes production more difficult because a lot of time is spent on setup operations when you have to change over to production of a new item. By introducing original, fully customized machines, we could raise productivity by getting rid of the non-productive downtime. In fact, we achieved an 84% increase in productivity at a very low cost.
In June 1989, the third stage of line improvements was started with the aim of further increasing assembly productivity. For example, a smaller U-line was created by the separation of the press processing. This improved the balance of the lines and removed the need for one of the operators. But was there a need for further improvement?
そうですね、改善点はまだまだこれからあると思うんですけれども、特にですね、入り口と出口を担当するというのが U 字の基本になっていると思います。それは品質の面で工程内不良が出た時に、先頭作業者がですね、ラインを止めてですね、いち早く手が打てるということだろうと思います。しかし今見ても分かりますように、 我々の小有事の場合はまだそこまでいっておりませんで、これからこの辺を改善しなければいけないかなというふうに考えておりますけれども。
The idea of separating the press operations from the U-line was to avoid stoppages caused by the long time required for setup operations. That setup time itself needed to be reduced. Before improvement, resetting the presses, including changing the jigs with manual tightening, took 16 minutes. Among the improvements, they decided to implement one-touch exchange. They managed to reduce the total setup time to 3 minutes 32 seconds, roughly 1/5 of the original time. Whereas manual tightening previously took 55 seconds, it now only took 16 seconds. The fourth stage of line improvement involved the introduction of automated equipment to 4 of the U-line operations. This halved the number of operators to 3 and increased productivity even further.
What about the figures involved? Well, the time taken for a carburetor to move on to the next process was between 25 and 30 seconds. The machines operate with a takt time of 20 to 30 seconds. With I-lines, productivity was only 12.5 per person per hour, about 5 minutes per item. But with the introduction of automation, this was increased to 33.3, which is less than 2 minutes per item. That was an impressive 2.7 times increase.
The deadline for completing the bye-bye strategy was the end of March 1990. A new strategy aiming at 0 defects on all the U-lines was introduced from April, called the UFO strategy, standing for U-lines, faults, 0.
The bye-bye strategy had been quite effective, but the situation still wasn't ideal. Productivity hadn't doubled, and 0 defects hadn't been achieved. So they hadn't yet found the final solution. But since 3 years had passed, they decided to formally adopt a new 3-year strategy. A new name and a fresh attitude, but of course this was in many ways an extension of the bye-bye strategy. A lot of effort was put in to reach the double productivity target within the first year before moving on in other directions. The basic feeling was that more waste needed to be eliminated and that setup needed to be further improved.
Yamamoto began his efforts to completely remove waste movements as the finishing touch to the bye-bye strategy. He invited the assistant manager, group leader, and chief line supervisor to join the project team. Every week they reserved time to effect waste elimination on all the lines using an all-out effort. Here are the results. Productivity had further increased, the number of operators had been further reduced, and the defect rate was also down. The bye-bye strategy lasted from July 1987 to March 1990. A total of 1,418 improvements were implemented during that 33-month period. Various subsystems, including the blue notebooks, supported the main strategy. Let's now take a look at a few of those. This is a type of warning lamp which is attached to both assembly and processing lines. Its purpose is to call the group leader for immediate action. It provides clear visual and oral indication of the location of a malfunction. These line stoppage signboards give a precise indication of why a particular line is temporarily out of action. An award system was implemented for each section. 8 items were evaluated, including efficiency, defects rate, and the number of improvement suggestions. Certificates are awarded to the winning section to serve as encouragement. Individual production target boards were set up showing the increase in hourly production from left to right as the strategies proceeded, with the target rate in red on the right. Production target boards for complete lines indicate the difference between the present production rate and the target rate, so that everyone can understand how fast they are working and gain extra motivation. Impressive personal certificates are also produced to mark the completion of special training programs. Every year, each section is given improvement targets, and progress checks are carried out every 3 months. This is called matrix development. In combination with general staff enthusiasm, these improvements greatly help the progress of the bye-bye strategy.
Well, there we are. We've seen how process raising and the creation of U-lines can greatly improve setup and increase waste removal. But that's not really the end of the story. The kind of improvements we've seen give a good base to work from. Each new set of improvements soon becomes the status quo, and then you've got to start looking at that with fresh eyes. In the factory we've been studying, there are still lots of types of waste in the process flow which must be targeted for future improvements, and zero setup time hasn't been achieved yet. And there's one more thing to remember. Improvements in the factory may lead to adjustment of parts delivery schedules, which could lead to problems with suppliers. They will need to be apprised of what's going on and help to coordinate their own production with yours. What we've been seeing in this volume is, of course, just part of an ongoing process of improvement. Process raising means the creation of a new base. Strategies, targets, trial and error, perseverance, enthusiasm, and a constant search for improvements. These are the keys to success with streamlining. We'll see you in Volume 2.